So beginning of every session, we'll do some questions from classified papers. So it will be like a revision for you. You can recall what we have already completed or discussed. So in the first question, figure 2.1 shows a sign that extended over a road. And it's written accident, slow down. A concrete block is there, a support post is there. And distances are also given, the force, the weight is also given. Now, it will switch on in a few minutes. This is a classified paper, so different topics like the questions are according to the, not in terms of the sequence of the topic, in terms of the block. So in this classified paper, you will find question from topic 1.1 to 1.8. So figure 2.1 shows a sign that is extended over a road. The mass of a sign is 3.4 exponent 3 kilogram. Calculate the weight. How we can find the weight of an object? If we have the mass, what's the formula to get the weight? We have
Mass multiplied by gravity.
Good. So weight is mass multiplied by gravity. So it's very important in physics, especially you learn the formulas. And in exam, 1 mark for mentioning, like writing a formula or showing substitution in the formula. You can write weight equals mass times gravity, or if you directly write weight is equals to 3.4 exponent 3 times 9.8. That both will, because this like showing substitution or writing a formula. But I always advise students to write formula. And then what's the answer here? 3.4 exponent 3 times 9.8. 3.4 exponent 3 means 3,400 times 9.8.
33,320.
33,320 newtons. But when we write the answer, 2 to 3 significant figure, we should always represent. So what I can do, I can also write this as 33. Yeah, 3.3 exponent 4, because point is here 1, 2, 3, 4. So I can also write as 3.3 into 10 to the power 4 newtons. Okay. So whenever you represent the answer, 2 or 3 significant figure, acceptable. Clear about this? Yeah. This is just a discussion. No need to copy this part. It's just a discussion. We will notes you will copy. The weight of the sign at a horizontal distance of a 1.8 meters from a center of the support post, and it produces a turning effect about point P. So about, whenever in a question it's about, means that point is acting like a pivot or a point of rotation. So P is a pivot or P is a point of rotation. Point P is at a distance of 1.3 from the center of the support post. Calculate the moment about P due to weight. So we need a turning effect moment. How to calculate a moment? What's the formula for moment? The turning effect.
Force multiplied by distance.
So moment is force multiplied by distance. So what force we will take? Because we need the moment of the weight. So weight is a force here. Weight is a force, and what is the distance from point P? What is the distance of weight? Like weight is acting downward. What is the perpendicular distance from point P? Because point P is the pivot. How much is this distance?
1.3.
No. Total is 1.8. Here it's 1.3. How much is this? Good. That's 0.5. Because look, the question is calculate the moment or turning effect about point P. So means we always need a perpendicular distance from P, 90-degree distance. This total is 1.8 and remaining is 1.3. So how much is this? 1.8 minus 1.3. So what we'll get? We'll get 0.5. And what about the weight? How much was the weight? We just calculated it was 3.3 exponent 4. So if we want a turning effect or the moment due to a weight, so it will be 3.3 into 10 to the power 4 times 0.5. So what's the answer? 3.3 exponent 4 times 0.5 or half of this? 60.
16,500.
So 16,500 Newton meter. So I can also write in three significant 1, 2, 3. So I can also say it is 16 exponent 3 Newton meter. Or 1.7. Look, what is the rule of rounding off? Whenever there's a 5, you have a 5 and next number is an even number, you don't add 1. You keep that as it is. But if it was, let's say, 1.75, when we have to remove 5 and there's an odd number, we add 1. So it will become 1.8. That's a rule of rounding off. So 16 exponent 3 or 1.6 exponent 4, both are the correct answer. Or 1.65 exponent 4 is also correct. Next is it clear? This one point, determining. The concrete block is positioned on the other side of the support post with its center of the mass at a distance of 70 centimeter or 0.7 meters from the support. What is meant by center of the mass? Or how we define the term center of the mass? Center of mass is what? It is a point where whole weight of an object acts. So the position or the point where the whole mass of an object acts, we call center of the mass or center of gravity. Actually, center of the mass, you will learn in higher grades that the center of the mass and center of gravity are not same, but right now you will consider them as same. So it's actually a point where Earth is pulling the whole body. That point is called center of the mass or center of gravity as well. The weight of a concrete block produce a moment about point P that is exactly cancel the moment of the weight. Calculate the weight of the concrete block. So what they mean here, that the turning effect caused by the weight balances with the turning effect. Like this weight is causing a turning effect. Which direction it will try to cause a turning effect? Clockwise or anti-clockwise?
Clockwise.
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 And the concrete block is there. The block of a concrete, its weight is acting downward. Which direction this will try to cause a turning effect? Anti-clockwise or counterclockwise? So because it is not rotating, if it is not rotating, the clockwise moment is equals to anti-clockwise rotation. When object is balanced, the total clockwise turning effect equal to anti-clockwise. The clockwise turning effect is what? It is, we always take a distance from the pivot. So what is the clockwise turning effect? It will be weight, which we already calculated in the previous part. The weight was 3.3 into 10 to the power 4 multiplied by distance from the pivot. How much this distance was? 0.5. Then equals to anti-clockwise turning effect. This force is unknown. This force is, you can say F or X or the weight. How much is the distance from the pivot? How much is the distance from pivot? This is 70 centimeter or 0.7 meters. How much is the distance? What is this total distance? Yeah. Good. That's equals to 2 meters. How we worked out it is equals to 2 meters because 1.3 here and 0.7 meters here, so the sum will be 2 meters. So here we'll write F into 2. So the total clockwise turning effect will be balanced with the anti-clockwise turning effect. So this 2 is multiplied, other side it will be divided. So we'll get 3.3 exponent 4 times 0.5 divided by 2. How much is the weight? What is the weight of this object? 3.3 exponent 4 times 0.5 divided by 2. You'll get the answer in newtons.
8,250.
So 8,250 and the unit will be newtons. Is it clear, this one? Question? So whenever they ask any unknown weight or a distance, you always consider, and you have a turning effect, you will always consider the clockwise and anti-clockwise turning effects are equal. Okay? The next we have is the concrete block is removed. The sign and the support post rotate about P in a clockwise direction. State and explain what happened to the moment about point P due to the weight as it rotated. First, what we did, we removed this weight, counterweight here. So as a result, there is no anti-clockwise turning effect. We remove this weight. So when we remove this weight, what will the new position of this sign? As it start to topple, this will be the new position. So now what is happening? Like this is a point P, a pivot is there. The weight is acting downward. So this is a weight which is acting downward. So when it topple, what will happen to the moment? The moment will increase, the clockwise moment. How clockwise moment increase? Because the distance from the pivot is increasing. In the beginning, when it start, this was a distance, only 0.5. But then when it start to rotate clockwise, the distance of a weight from the pivot is increasing. That is why maybe you have experienced this thing. Let's say if anything topple in the beginning, it rotates slowly. But once it reach a halfway point, then it rotates faster. Why it is like this? Because when the object rotate or turn, the distance from the pivot to the weight increases, so the moment or the turning effect will also increase. So what happened to the turning effect? The turning effect will increase because the distance from the pivot will increase. So there will be, the center of the mass won't change. Center of the mass is like the distance of the center of the mass to the pivot will change. That's why, example, if you have a bottle which was originally, let's say, vertical, then this is a new position of the same bottle. And this is another position of the bottle. So we have three different positions, and what will happen? The center of the mass will get lower. It will gain stability. This is the center of the mass. The center of the mass will get lower. But the weight, so this is a weight acting. So the distance, like if this is a point of rotation, so distance from the pivot is increasing. If a distance is increasing, the moment or the turning effect will also increase. Is it clear? Discussion? Any doubt in this?